This is lecture number 7, so recorded video lectures. Um, as you know that we are studying the rate equations, and in the last lecture the 3-level laser, and now here is 4-level laser. And as I mentioned like in my previous video, that these rate analysis, rate equation analysis, I'm giving you as an assignment. Many things are solved here, many points are explained here, equations are mentioned here, and you just need to expand it. So starting from this equation, the rate of change of fourth level in a 4-level laser system is a pump level. Okay, so W12, this is the probability between first and fourth level, and N1 first level, and 4 this is the difference of these two levels, and N4 by tau 4. Tau 4 is the time, decay time. Okay, so you know that this is a pump level here. Okay, this is ULL here, this is LLL here, this is ground here. Okay, so 1, 2, 3, and 4. So W14 is the probability of atom transition from level 1 to 4. Tau 4 is the total lifetime. Okay, and 1 and 4 is a difference. Okay, atoms available at the ground. Okay, this is subtracting, which is supposed to be pumped to the level 4. Energy from the pump level flow by decay to ULL. Okay, and from then ULL to LLL. So tau 4 represents the total lifetime of the pump level 4, which is usually very short. It's a pump level. Okay, and which can decay to level 3, 2, or 1, and it can be written like this: tau 4, tau 4 3, tau 4 2, tau 4 1. Okay, from 1 to 3, 3 to 4 to 1. Okay, 4 to 3, 4 to 2, 4 to 1. So we know that to generate an inversion, the majority of pump atoms decay to level 3. Then after that, the lasing happened. Equation ULL. Okay, so N3 is a ULL. So you can write like this. You can go through the last 2 lectures. You can understand here. But you need to expand definitely in your assignment. Tau 43 is the decay lifetime. Okay, to the ULL from 4 to 3rd level, 4 level and 3rd level, and tau 3 is lifetime of the ULL. It's longer, as you know that. So energy flow into ULL from above via decay from pump level we know already, and the number of atoms per second being population divided by the decay lifetime from the pump level, which we have already studied. Energy flow out of the ULL by decay to level 2. Okay, so from 3 to 2, and here is the lasing. So the rate equation of the low lasing level for N2 can be like this: N4 N3 minus N2. Okay, so lasing is happening between N3 and N2, and these are decay times. Tau 42 decay lifetime from the pump level directly to the LL, obvious, and tau 32 lifetime of laser transition from ULL to LLL, that is pump level to LLL, that is ULL to LLL, and this is lifetime of LLL to the ground. Okay, so first term is representing what? LL directly from the pump level. Okay, and rest of the things are explained here. You can go through in a practical laser. This term is ignored. This term is ignored. Okay, So what I'm saying, the loss of population from pump level which does not contribute to the laser action. Okay, so a rate equation, um, the rate equation equated to zero under steady state condition. Okay, depopulated, populated, depopulated, populated, depopulated, populated. So it's a steady state condition. So it's equating to zero. Then you further uh, solve it algebraically. Okay, rearrange. You get these values, and then the population of N4, which is a pump level. Uh, so it's pumped to N4 and then immediately go down to ULL where it stays. Okay. So what it's saying here, the population of N4 in relay will be much smaller than that of N1. N1 is ground level, which is obviously the natural level to be populated. Okay. So equation 9 to modify, and then you will get this one. Okay, this one, go through and find out how it comes. Okay, just method of algebraic solving and rearrangement of the equations. Okay, so after that the rate equation for ULL can be written like this. Okay, equal to 0 in steady state as well. So it will be like this. And what it's saying here, in practical 4-level laser system, the tau 3, the lifetime of ULL is much longer than tau 4 and 3. 4 and 3 from pump to ULL. Okay, so lifetime, decay time, lifetime of the ULL is much longer. Okay, this is one of the condition to create population inversion. Okay, so the population of the pump level will remain very low. Okay, while the population UL will remain very large. Okay, so here the rate of LL to 0 at steady state. Okay, and 4 over tau 42. Okay, now further this yield this thing. Okay, combining these number of equation 10, 13, 14, we obtain an expression with, this is one of the condition, that delta n has to be greater than 0 for an inversion. And these are further steps. If you use this equation and substitute the n3, n2, you will get this one, rearrange it, okay, expand it, then you can understand, and it's part of your assignment definitely. In a particular laser, the decay time from the lower lasing level 2 to 1 is very fast. Okay, 2 to 1. So this term is insignificant against the first term, where tau 3 is much longer. Okay, so now you have this equation W14N. This is tau 3 and 1. So this one, what it's saying, between as compared to T3 to 1 is very fast. Okay, so it's ignoring here, and this equation will be like this. And after that, if you when you expand these equations, and when you do it by your own hands, and you will understand more these things. There are some things you mentioned, that the population inversion results when any pump energy is applied. ठीक है, you can see here, आपको यहाँ पे नजर आ रहा होगा the pump power. Okay, this is N2, this is N3. Okay, so with the increase of the pump power, these N2 and N3 with the time is also increasing here, here. Okay, so lasing is happening between the N3 and N2. So this inversion here, this is the portion. This is the portion where inversion is generated. Okay, between the N2 and N3, and this is the lasing portion. Okay, so now what is saying here, unlike the three-level system where inversion occurs only after threshold pump rate is reached, strong pumping, threshold pumping, if the pumping level is low, then you cannot have population inversion. Okay, but in case of four-level system, the population inversion actually occurs easily, more easily. Okay, so most common in laser systems, the helium neon, argon, carbon dioxide, YAG lasers, these are four-level lasers. Okay, in many cases, it may appear that lasing may occur even a small pump energy. So these are the things which are related to the four-level system से relate करती हैं. तो मैंने जैसे पहले बताया आपको कि ये आपकी असाइनमेंट है, 3-level लेज़र, 4-level लेज़र सिस्टम को, एंड इक्वेशंस मेंशन्ड. इक्वेशन बहुत सारी मैंने लिख दी हैं, बहुत सारी किताब में भी हैं आपके, और आपने ये करना है कि इसको एक्सपेंड करना है और assumptions को कंसीडर करना है और ये सॉल्व करनी है. यही आपकी असाइनमेंट है. ठीक होगी बात.